Presenting one of its kind, Dr. Haribhakti's Atlas of Robotic GI Surgery using SSI Mantra, a journey of precision innovation by the experts. Project initiated by Dr. Sanjeev Haribhakti, co-edited by Dr. Tushar Dave and Team Kaizen. Published by Haribhakti Education Foundation, supported by Kaizen Hospital and SS Innovations.
Hi, I'm Dr. Tushar Dave, co-editor of the Hargis Atlas, which is Dr. Haribhakti's Atlas of Robotic GI Surgery. So in this section, we are going to be talking about the entire OT layout, how we go about it, how we prepare our table, and how we prepare our arms for the surgery. In this, we will cover the first topic will be draping and how we put the instrument sterile barrier onto the arms, and then we will take forward giving you a dummy case of fundoplication on which it will show you how all the arm position has to be done, how docking has to be done, and how cannula mounting has to be done in those orders perfectly. So in this draping part, we fix the drape first onto the magnetic gear, onto the magnetic latches. The second will go at the sterile cannula mount area. This will be the mount area for the cannula, and this is the instrument sterile barrier which has all the disc inside, which is going to connect our instrument to the robotic arm, and this has to be connected properly. And once this is done, what we do is we check whether the drape is moving freely or no. This movement has to be free so as to avoid any errors during the surgery. If the drape is too tight, then it can go into fall. So for demo purpose, we are showing a case of fundoplication. This is the head end of the patient, this is the foot end. You can see the table in leg split position, and head has already been given for the position of pneumoperitoneum. And this is the arm layout as per the left arm configuration. The retraction arm is on the left side of the surgeon, so this is called as a left arm configuration. We initially create the pneumoperitoneum using a Veris needle. That is the standard procedure that we follow in our hospital. And once the pneumoperitoneum is created, we go with the standard port placement. Can I have the camera port, please? So the camera port goes first. With a blunt roca, we insert the camera port. Then under vision, we put the remaining trocas. The camera goes in, and whatever the location we have marked as per the pre-op planning for the perspective port position, we go for that position. We will see and we confirm with the needle the position is correct, and then keeping the camera in the cannula sheet itself, we put the remaining ports inside. You can see the port coming inside, and my camera is very well safeguarded because it is in the sheet. Do not put the camera ahead of the sheet, as in this step you can injure the camera. So again, what the position was decided pre-operatively, we are putting the ports. So this is the left working hand coming in here. Okay. So once this is done, we will go for the patient position. Patient position, I want head up and 15-degree left up. That is enough. Keep the table to the lowest and just give a 15-degree tilt. on the left side, left arm. Yes, that's it. Good. So now I have achieved my final position for the surgery. In this position itself, we are going to do the entire surgery. So this position has to be fixed first, and then we bring the arms for the docking. Do not do this in a reverse fashion, that you dock the arm first and then go for the port position. In that patient position, in that what can happen is either the port can dislodge, you can incur harm to the patient. So avoid those things. Get a clear-cut position first of the patient and the table, and then go for the arm docking. Once this step is done, the first and foremost thing is defining the target area. So my target area of G junction is here, my port is here. So I will align the camera first. The camera will go exactly in line with the target area and the port position, so that I get the optimal vision and I can get a proper range of the vision also. So can you bring the boom up of camera? Get the camera boom ahead. Yes. Boom up. So by pressing the clutch button here, with a single button also, with single finger also, I can easily maneuver the entire robotic arm. That is simple function of the clutch button, and the joints are very smooth. Yes, go for the position. Yes. So what we do is, once we have aligned the camera, we do not mount the camera to the camera port. So the first arm that we put in position is the camera. So that always our port position, the port, camera port, the target organ, the entire boom or the entire arm cart is in one line only. That is very necessary, because that is going to be the central focus of our dissection, right? So we do not connect the arm to the mount first, so that we can have this range of motion freely. So as to when we will show you ahead, when we put the instrument, we can utilize this in the free motion. Next, I will go for the right and left working hands. So for that again, please do it. So again, bring the arm to the cannula. Bring the arm to the cannula, not the cannula to the arm, so that we do not disturb the port position or the port inside the abdomen. Okay. Once this is done, we open the arm properly. We have to make sure that all the joints, this is the tool interface, and these are the active joints. These active joints should be always in mid-range, and accordingly the setup joint, there are 3 setup joints. This is 1, 2 and 3. So these 3 setup joints also has to be in a mid-range position, so that we do not get any force during the surgery. And how to get that mid-range position? We have a marking below, which is showing the green, yellow and red areas. If the movement is too wide, if the arm is too close, too flexed or too extended, it will go into the red area, in which we will have faults showing up again and again. It will show joint limit reached. So we will try to avoid that. Okay. So next I will go for other arms. This is going to be my left working arm. Boom up. So again here, I am not going to make much movement of my robotic port, but I will use my arm itself. Hold it like a gun, press it. What I do is, I utilize my thenar muscles and I align the port. Once this is aligned, release the lever and lock it. You will hear a click, that means it is locked. Okay. And then I will open the arm and give its position. Now this is going to be the retraction port. You can see how lateral it is. Again same, boom up. Yes. I am taking my arm in the position of my retraction. Okay. Again hold it like a gun. Take the arm there. Now you can see here, the joint is too flexed. This is the setup joint number 2 and it is too flexed. It is already in the red area. So I will ask my assistant to take the arm cut a little behind. Can you take arm 3 a little behind please? So that it comes into the green zone. Stop. So once this is done, again I will go for the position of my cannula.
तो आगे आने दो, आम आगे आने दो, सेटअप स्ट्रेट हो रहा है एकदम, तू देख रहा है।
बस that's it. Okay. So now I am done with my arm placement. So the next step is, before going ahead, what I prefer to do is I like to confirm the hourglass configuration of the arms. In this hourglass, we should be able to see all the robotic arms coming and converging at the port position, and the tool interfaces of all the robotic arms should be diverging again after the port position, after the cannula. Okay, so you can see how it is converging and diverging. So this position is very much necessary to get the maximum range of movement, and this can be altered in the surgery also. During the surgery also, it is very simple to change the range of motion position. What we have to do is just press the clutch here, and I can change it simply like this. I can go with one arm also. I do not require any other assistant also for this particular step. Okay. So once this is confirmed, the position, everything looks good as per the target, I will go ahead with the instrument placement. And all the instrument placement that we do is always under vision. So, give my left working instrument, FBF. This is the FBF, which is going to be the left hand instrument. With just 3 fingers, we can easily put the instrument onto the tool interface and the actuator. It can easily go inside, and you can hear a click. Once this click is there, we will see advanced instrument or instrument housing. First, it will come as instrument homing. Once the instrument home, what does it mean is basically the tool interface and the instrument both are aligning its disc so that it can give us the maximum range of movement whatever is possible. Once this is done under vision, I can change my position of the arm. So suppose this is the target area, I am too close to the target area, so I can withdraw. I am holding the clutch button here. In this also, the instrument clutch button, there are 3 functions. First is, when I simply just press this, you will see on the screen there is an advanced instrument. On the advanced instrument, I can just make this movement. I can just go in and out of the tool interface, right? But suppose if I keep it pressed, then I can do both. I can move the arm around. So I can move the arm around like this, and also in and out on the arm. So this movement can be done by continuous long press. Okay. Now, again, the retraction arm, you can simply go inside, hear a click, and do it. Okay. So now once this is done, I will show the right hand working instrument. Again, everything is done under vision so that we do not injure the organs, we do not cause any iatrogenic injuries to the patient, right? Always do everything under vision. Yes. So now once we have all the instrument inside, what we do is we get all the instrument in the target field. So now my left hand is not in the target field, so I'll get it that. Yes. My retraction arm, you can see the difference, the angle at which my left arm is going to be working and my right arm is going to be working on. And you can see the retraction arm, it is very acute, so that the entire configuration of the arm is different. The working arm will go and work like this, whereas my retraction will go and work like this, so that there is no clashing of the instrument inside and outside. So this is called a staggered height or offset port placement. So before giving controls to my surgeon, what I do is I place all the instrument under vision, and from that point of, after that point, the surgeon can take the control. Once all this is done, then I will finally go and put I will connect the cannula to the robotic arm of the camera. So again, connect here. It's a very simple mechanism. Just place it inside, release and pull. So you will lock, right? And this also has similar function. One press, you can take the actuator up and down. If you keep it long pressed, then I will see the entire movement like this. I can go in any direction, right? Can you insert the camera, please? Okay. So we have camera inside. We have all our instruments inside. All our instruments are docked, or you can say attached to the robotic arms. So now the most crucial step is that is the docking. The entire docking process, what does it mean is, once you press the clutch button and the docking button on the arm part, the digital control trolley, so what will happen is it will release the parking actuators, which is going to be lifting the entire boom and immobilizing that particular arm. So that is very much important, so that the arm does not move in any direction during the surgery. So for that simple function is, I will be pressing the clutch button here. This is the secondary clutch button. So once I press this, I will ask my assistant for that particular arm. He is going to be pressing the docking button there. So can you please press, I have pressed the clutch. Can you please do the docking of arm 2? You can see the light blinking, that is, it is actuating it, is reading it, and accordingly once that is done, the light will be a fixed green light. That is a thumbs up, go ahead for us. Okay? तू दिखाना तेरे side से. So for retraction arm, I am pressing the clutch. Clutch is pressed. Please dock arm 3. A constant communication is very much essential here, so that everybody follows the steps properly and there is no miscommunication, because each and everything is mechanized here and we don't want to give any kind of injury to our patient. So once the arms are everything placed inside, we have docking done. What we have to do next is, this is a modular design. You can see all the 4 arms are free. It is not a single boom design. It is a modular design. So we have to feed the information to the machine that where the arms are lying. This is done by the laser grid line that you can see below. So right now there is no alignment of the lasers. So first and foremost, again, start with the camera. I will make sure the laser is properly aligned here in line of my dissection, in the line of my target organ. So once this is done, all the remaining 3 lasers has to be set to this line parallelly. So again I will come here and I will adjust. This is the one adjuster given over here to adjust the laser. Once this laser is adjusted exactly parallel for arm 2 also and arm 3 also, all the 4 lasers has to be in a proper parallel configuration. Once this is done, I have to give input. So when I give input, the machine is going to start reading its position and it will assess where all the arms are, so that it can again align itself properly and help in the instrumentation and the working dynamics of the machine, right? So once this is done, we will show it on the console, how to check whether this configuration has been accepted or not, or whether it has been read properly or not by the machine. So now the laser input has been given. I have selected my configuration to the left side, since my retraction arm, 4th arm, is on the left side, and then again I will go here and see the position. This is the 3D interface. Can you come closely and show? This is the 3D interface. Now in this, I have to check whether all my arms are perfectly lined or no. So in this, can you see all the arms are perfectly parallel to each other? The configuration hourglass is maintained and it is showing us very well. All the arms converging and diverging after the ports. So this is a go ahead that the system has read the setting properly and we can proceed with the surgery. So once this is done, I will confirm with the roll check of the instrument. Advancing, everything is been turned off, because if the instrument is in advance, the surgeon can't use the instrument. So once all those is done, I will check everything properly, roll everything is maintained. Once this is done, I will give command to my surgeon to take over and start the surgery. So now coming to the part of laparoscopic assistance. So basically what we have to do is, in between the 2 arms, we have to place a assistant laparoscopic port. But it should not be in the line of robotic port, because if we put a port over here, the movement will be restricted by the robotic arms. So the retraction or any activity by the assistant won't be appropriate or won't be adequate. So what we have to do is, in between these 2 arms, the midpoint, suppose the gap maintained is 8 cm. So around 4 cm I will take the midpoint, and again 4 cm below, 4 to 5 cm below, you should put a laparoscopic port. So once we do that, we will be out of the range of the arms. Suppose, so now this is the appropriate position of the laparoscopic assistant. So I can have a wide range of movement like this. Even if my arm is working high up on the roof, so still I have a very good range of motion. But if the same thing is here, I won't be having that range of motion. Okay? And in case, what we also do is, to avoid the angulation or to avoid any clashing, we take instruments which are longer. So we use bariatric instrument also in non-bariatric patients. What happens is, you can see that clearly, you can see the difference over here. We get some 7 to 8 centimeter extra. And again, what it does is, it will completely bring out the working end of the hand outside of the range. So again, I have a very good motion here. I can go inside, and the angulation of the laparoscopic instrument to the patient and angulation of the robotic instrument to the patient, it has to be different. They both can't be on same level and do the same work. So what we do is, we place the port a little lower and we go with angulation. So we have a very acute angle compared to the robotic arms. So once we do this, we have a very good working dynamic. I have good range of motion also, and I can assist properly, because most of the time the assistant has to work on the floor, not on the roof. So my instrument will not go down. My instrument from outside, it will go up only. So make sure that you have a very good range of movement, and you always check before going ahead and putting the laparoscopic port. Because once you put a port and you are not getting adequate retraction or you are not able to work properly, you have to go and put in another port. So plan properly and then go for the port insertion. Don't be in a rush. Plan it properly and then you go for the port positions. And again, use bariatric instruments so that we have a very good range also, because the arms are quite long. So you can't be standing in between, because or else you will get hit by the arms. So you take a bariatric instrument that can solve two purposes. It will take your hand out of the range of the arms, robotic arms, and again the angulation of the tissue to the instrument will be different compared to the robotic arms. Okay, that will be all. Thank you.